I'll discuss it with So, yeah, everyone, we are starting. We are starting, okay? Right.
Were you the one in the other room? I was talking to the teacher of my house.
So please be seated, we'll start. That's all, the students? Oh, okay, right. We will start anyway. Yeah, and I'll be putting
Where do you sit? Stay here?
right, so sacrifice to remember everybody's name. Okay, so I think
Sir, what's my name? Give me some time.
Class number 10, 5
You
years.
are
22. Brother can
Okay, so
memorize the whole periodic table
I
without
cannot
my
memorize
name.
the grade of the students.
okay, right.
22.
You are Hannah.
Yes.
Yeah, and then we have Sarah here. We have
Oh, hi, Ramesh.
the
Wait, are you actually gonna?
Sabal.
Yeah.
Sabal. Okay. Yeah, and we have.
Do you know what their name is?
Give me a moment. Give me a moment.
Sir. She's.
Are you Eric?
Yeah,
Eric.
yeah.
You're Eric.
22.
And
And Dale. Sir, how about me? Do you remember my name?
You transfer. You
Yeah,
student.
she's studying chemistry. Sorry, it's okay.
okay, right, and then we have and
Where's Alec?
Oh shit, where's Adam?
Oh, he's gonna come later. We have stuff to do.
let me just
Sir, Alec is
I'm
coming.
sorry, I don't remember your name. I'm really sorry.
Yes.
Sunny.
Yes.
Oh, right.
Sunny.
Sorry.
So we
Yeah. So and then we have D.
Her name's like legit like me.
Sir, Alec is gonna come. Sir, he's
Late.
coming.
Just say it late.
He's just gonna
Okay.
be late.
Right. Then I'll mark it late here as well.
Yes.
Right. Okay. So let's start. Now we take attendance. Okay. Yeah. So
James was
I will record for you. So yeah, you
always
can.
right.
Yeah. You can return to your seat first. Yeah. Yes. Outside. For
House warden. House committee.
Oh, okay. Yeah. So we'll look at the answer for the, I think we stop at which question? Question number 2, yes. So we can use the equation M1V1 equals M2V2. So write this out. Dilution equation. Right, so dilution equation. It is M1V1 equals M2V2. So this is the condition before dilution. And this is the condition after dilution. Sorry. Okay, so this is the condition after. So 2 means after dilution. And if you have a red pen and a blue pen, take it out. Look at the question. A 2DN cube 1 molar sulfuric acid. So that means 2DN cube and 1 molar. These are the starting concentration and volume. Yeah, and then we have after dilution. So what is the volume of 16 molar? Sorry. So these are the conditions that you want to prepare. A 2DN cube 1 molar sulfuric acid solution is prepared. Underline the word is prepared. So the phrase is prepared means this is the condition after dilution. It is implied. Yeah, because when you say something is prepared, that means this is the outcome. This is what you get at the end of the reaction. So can you put down B and C in here? What about the concentration of the starting solution? It should be 16 molar, right? You all have the paper with you. Yeah, you still have the paper, right? So can you put down the starting concentration is 16 molar? So 16 molar. And they are asking you what is the volume of 16 molar sulfuric acid required. That means you want to know what the starting volume is. So can you all plug this number in to the equation? So let it be X. So let B be X. You will have M means C. So M means C because polarity means concentration. Okay. So you can use M or C. So molarity means concentration in mole per dN cube. So when you do 16X is equal to 2 times 1, what do you get? What is X? X is 1/8. X is 1/8, which is 0.125. Right, yeah, which is 0.125. So what units should we put in here? This is in dN cube. So how do we convert that to dN cube? Times 1,000. So when you multiply by 1,000, you get the answer A, 125 dN cube. Right, okay? Okay, so next up, which substance reacts with water to form an alkaline solution? Okay, so we can eliminate. So we can answer. We can tell if A and B are the answer very quickly because what is A and B respectively? Which one is a metal oxide? Which one is a non-metal oxide? A and B. A and B. Question 3. We're looking at question 3 now. Which of the following substance reacts with water to form an alkaline solution? So A is a non-metal oxide, right? Yeah, so can you put down the acid-base nature of oxide? So acid-base nature of oxides. So we have 2 main types of oxides on the periodic table. We have the metal oxides, which are basic. And we have the non-metal oxides, which are generally acidic. So you can put down generally acidic because there are some exceptions. For example, what are acidic metal oxides? We have carbon dioxide, nitrogen dioxide, sulfur dioxide. So these 2 gases are what causes acid rain. Okay? But then there are exceptions. So put down the exceptions. Can you all think of one non-metal oxide that is not acidic? There is a non-metal oxide that is not acidic that we rely on every day. It's water. Water is H2O and it has a non-metal in it. It is the neutral non-metal oxide. So there are exceptions to this rule. So underline the word generally, because they are exception. This is the exception. Yeah, metal oxides, they are generally basic. So, and there are many basic oxides. For example, CaO, MgO, NaO, Na2O. When you see a metal in the oxides formula, most likely it is basic. Okay, it is basic. So that means when answering this question, which of the following substance reacts with water to form an alkaline solution? B is a likely option. Okay, because B is calcium oxide. When we add metal oxide into water, what do we get? What is the general formula? We get metal hydroxide. So if the example is CaO, what's the formula of the hydroxide that results? CaOH2. Because CH is from group 2 and OH is a charge of -1. So when you do Ca2 plus and OH minus, when you do crisscross rule, you have CaOH2, right? And why is this basic? Because you see hydroxide ion in there. It can dissociate into Ca2 plus and OH minus. Therefore, it will cause the pH to be greater than 7.
Oh.
Wonder. I almost thought I was living next to the street. Okay. I mean, it's like sitting next to the street. Okay. Yeah. So okay. Thank God. Okay. Thank you very much. So we have alkaline oxide here. So next up. Oh, this I think we may have discussed up in question 4. I think question 4 rings a bell. Which statement is correct? Are all bases alkaline or are all alkalis base? Which of these statements are correct? Let me write them both down and show to you. Write these two statements down on the board. All bases are alkaline compared to all alkalis are base. There's only one correct statement here. The second one. Why? Because alkalis are a small subset of base. So what is that? Alkalis are soluble base, which means they are a small subset of base. So they are a subset of base. So to show you this set and subset concept, you can draw a circle. If this is base, if this circle surrounds all known bases, then alkali will be this small subset, which you'll find inside the larger base circle. Examples of alkali include, does anyone remember? What are some examples of alkali? Ammonia, and then there's all group 1 hydroxides. Okay, so all group 1 hydroxides like NaOH, KOH, these are alkalis. Yeah. Something that are not alkali are known as the insoluble base. Okay, so you can see that insoluble base and alkali, they both live under the same roof. The roof being base. Yeah, the term base encompasses alkalis and insoluble bases. So you have soluble base. Alkali is just another name for soluble bases. So you see the word base in both of them. So therefore they are under a larger family called base. Okay? So some examples of insoluble base include most metal oxides and hydroxides, except those of group 1. So except those of group 1. Okay? And lower group 2. So lower group 2. So where are the group 1 and the lower group 2? So you have in here, draw the periodic table, just a small slice of the periodic table. We are looking at the group 1 and 2 elements here. So this is group 1, and this is like group 2. And you have in here barium and strontium. They are the lower group 2 metals. Their hydroxides are soluble. Okay? So you can put down all group 1 and lower group 2 hydroxides. So sorry, I didn't use that. So and lower group 2. That means we can write a few things down. We have Li, Na, K. If I have Li2O, LiOH, Na2O, NaOH, K2O, KOH, BaO, BaOH2, SRO, and SROH2 compared to a bunch of other metals like Fe, Cu, etc., like Mn. Yeah. So what do you think are the solubility of these oxides? MnO, FeO, FeOH2, CuO, and CuOH2. Which of these are alkaline? Which of these are base? Insoluble base. Yeah. How many soluble bases or alkalines are there here? We have 10. Where are the 10 soluble bases? So these are soluble bases. All group 1 and lower group 2 oxides and hydroxides. Okay, so oxides and hydroxides, they are soluble. Okay, so this is lower group 2, you see this is group 2. Barium and strontium, they are in lower group 2. And every other thing, they are insoluble bases. So you just have to know group 1 and lower group 2 therefore. Any other thing other than group 1 and group 2 oxides and hydroxides, they are insoluble base. Okay, and so they live here. They live here. So the green things, they live in here. Okay, so this is where the green stuff lives. This is where the red stuff lives. And the whole thing, we call it the base. Okay, this is the largest substance. Is that clear? This you have to remember. There's no explanation to this at this level. It's beyond the scope of the SED explanation. Yeah, but we have to know this too. So the answer to this question, therefore, statement 3 of question 4 should be eliminated. Statement 3 of question 4, which means you can cross out C and D instantly. And this comes down to either A or B. So all bases are ionic compounds. Can you think of a counter example? What is the base that is not an ionic compound? NH3. Okay, so you can put down most bases are ionic. Some are covalent. So some are covalent. Why? Because bases include 3 types of things. The metal oxides, the metal hydroxides, and ammonia. So metal oxide, metal hydroxides, and ammonia. And you can see here metal oxides and hydroxides, they are ionic. Why are they ionic? Because you will have a metal ion and an oxide ion in here. And what about metal hydroxide? You will have a metal ion. What is the charge of hydroxide ion? 1 minus. So we put OH 1 minus here. And then ammonia. Ammonia is not a group of substance but a single substance. What is the formula of ammonia? NH3. Yeah, NH3. No, just NH3. There's not a minus. Okay, you mix it up with NH4 plus. NH4 plus is also not ammonia. That's ammonium ion. Ammonium ion. So metal oxides include like Na2O. So these are certainly ionic. Okay, and then hydroxide include things like NaOH. This is also ionic because it has a positive charge part and a negative charge part. Ammonia, you see I did not use any color because there is not an ion inside ammonia. This is a covalent compound. So can you all put down ionic? Because it has ions, that's what ionic means. And covalent. So covalent because it's not ions. Okay, so no ions in ammonia. Yeah, so therefore we can cross out statement 1 in question 4. The answer is void. Okay, question 4, void. Lime water, back to form 4. What is the chemical formula of the chemical in lime water? COH2. So can you put down lime water is COH2? And I would like to remind you of the lime cycle again. So lime water, there are a few things that are students often confused. I want you to write them all down. Lime water, quicklime, slaked lime, limestone, If they all sound similar to you, well, bad news, okay, because they are all different. Well, two of them are the same. Okay, let's find out which two are the same. So we have limestone here. We already know that lime water is basically a solution of calcium hydroxide. So we have CaOH2A2. What about the rest? Which of these three things do you recognize? What is quicklime? Calcium oxide. It is calcium oxide. Okay? Slaked lime is calcium hydroxide as well, which means they are really the same thing. So slaked lime, okay, when you filter it, you'll get lime water. So when you filter slaked lime, you will get lime water. That's because slaked lime is both solid and aqueous calcium hydroxide. When you filter off the calcium hydroxide solid part, you will have only the aqueous part left, you see. So this is solid plus aqueous. When you filter off the solid part, that means we cover it. What do we have left? We have only the aqueous part left. So this is the aqueous part, called the lime water. What about limestone? You all should know limestone if you have attended the makeup class on acid rain. Calcium carbonate. Okay. The term limestone is synonymous with a few other terms that you will also find in question. It's synonymous with marble, with chalk, okay, with what else? Okay, with like a clamshell. You know, all these things, they contain calcium carbonate. When marine organisms die, okay, their shells, they will be crushed by the high pressure and high temperature, and they turn into these rocks called limestone and chalk, okay, and also limestone. So these are the four things that I think students often confuse. Okay, you need to know which is which. So can you now put down what is lime water? Is it a solution of calcium hydroxide? Is it a solution of calcium oxide? No. What is calcium? What is lime water? A solution of calcium hydroxide. Yeah, can you correct statement one here? Yeah, not because I wrote something wrong here, but because that's what makes it a wrong answer. So cross out oxide in statement one. Replace it with hydroxide. Can lime water react with dilute sulfuric acid? Yes or no? Yes. Why? Because calcium hydroxide, just by looking at the hydroxide part, you know, what is hydroxide? They are base, and base can react with acid, right? Yeah, so write down why. Statement 2 is correct, because it is a base, and base reacts with acid. So statement number 3, is it corrosive? It is not. I mean, if it's corrosive, you won't be using it when you are in Form 1. Okay? Yeah, because that's just irritant, okay, at best, okay, irritant, not corrosive. So we have, so statement 3 is incorrect. So the answer is boy, 5 boy, okay? So next, we have, okay, compound X is a white solid. When dilute HCl is added to it, colorless gas bubble evolve. What can you deduce from this experimental result? Okay, there are a few chemical tests that you should know about since Form 4. There is the silver nitrate test. What does it test for? Chloride, not chlorine, but chloride. Okay, can you put down what it tests for? So it tests for chloride, Cl minus ion. And there will be positive and negative test results, like the COVID test. Okay, so a positive result and negative test result. What is the positive result? White precipitate. Okay, but I would like you to write down the color changes there from clear to a white precipitate. A clear solution will form a white precipitate. And if there's a negative result, it will remain clear. I don't want you to just write white precipitate. You have to say that the clear silver nitrate solution will turn white. That's what you should write. So remains colorless if there is a negative result. Negative result means there is no chloride ion. Just like when you do a COVID test, negative result means you don't have So, what other tests do you remember? There are quite a few. Now maybe you inform 5. Other than this one, test for water. What is the chemical that we can use to test for water? No. Anhydrous copper sulfate. Okay, if all of you combine your answers together, well, then yeah, you get the answer. Okay, yeah, you have this test. Pink agent, anhydrous copper 2 sulfate. If that's too much to write down the formula. Okay, also do that for silver nitrate. Silver nitrate has Ag plus ion in it. When Ag plus reacts with chloride ion, they form a white precipitate. So this is a white precipitate. These are both colorless though. And then they are aqueous. And this is a solid white precipitate. So they will ask you to write an equation for each test. So this is the equation for the first test. What is the equation for a second test? So, like you all just mentioned, copper 2 sulfate test for the presence of water. Okay, you can't use this to test for the purity of water. Why? Because if you add muddy water onto this chemical, it will still turn blue. But does it prove that muddy water is pure water? No. So not yet. Muddy water is not pure water. You can't drink it. You see. Yeah. So you can only test for the presence, but not the purity. So write this down. You cannot test for the purity of water this way. Even impure water will give you a positive test result. So the positive result is from white to blue. Okay, from white to blue. And the negative result is that it remains white. If you add a few drops of alcohol onto anhydrous copper sulfate, it remains white. Okay? That's copper 2 sulfate. Write down the formula. CuSO4. And as usual, we can write an equation. CuSO4 plus 5H2O will form the hydrated salt CuSO4 dot 5H2O. This is a blue solid. This is a blue solid. And this is a white solid. This is why we go from the white to a blue solid in this reaction. You need to remember an equation for each of these tests. Okay, this is the equation. Also known as stay simple. Solid, liquid, solid. That's the second test. And here we have our third test, and then also a fourth test for the same question. The third test, okay, is to use any accent. So any accent. For example, like in this question, you use hydrochloric acid. You can test for the presence of carbonate ion, CO3 2 minus ion this way. Any acid will do. So can you put down one more, H2SO4? That's because when you react H plus with carbonate ion, so this appears in the long questions section. You see this in here. This is why you need to know this equation. For question 11, A1, you have to write down this ionic equation. It's 2H plus carbonate forms CO2 and H2O. And if you don't know where this equation comes from, you can write HCl and H2SO4 and try to find out the equation. Okay, let's do this together. When acid reacts with carbonate, what are the products? What is the general equation for acid and carbonate? Salt. Salt water and carbon dioxide. Yeah, so that means you will have water and H2O on the right. The reason why I don't have to write any salt in here is because we are looking at only the negative ion part of carbonate. We don't have the positive ion of the carbonate here. So the positive ion can, usually you will have a positive ion like this. Like when you have HCl plus like maybe Na2CO3. So can you all complete this equation for me? What is the salt? Yes, and then you have CO2 and H2O normally. But what makes this equation special? is that it doesn't have the sodium ion. It doesn't have any metal ion. Remember the exercise I gave you all on the writing of ionic equation? What do we split? What do we not split? When we write, we only split aqueous substance. Any other thing, whether it is gas or liquid, we spare them, we don't touch them. Okay? So when we balance this equation, we have this. Okay, so what will this split into? Quick revision. What can you split 2HCl into? Remember there's a 2 in front. How many H plus and how many Cl minus can you get out of 2HCl? 2H plus and 2Cl minus. So write down 2H plus, 2Cl minus. What about when you see Na2CO3? Note that this number 2 is not the same number as this 2. 2 Na plus and CO3 2 minus, right? CO3 2 minus. Now, what about this one? What can we split 2 NaCl into? 2 NaCl. 2 Na plus and 2 Cl minus. So everything else, you just copy it. And look at what you found. You can cross the, what are the spectator ions? Na plus and Cl minus. Right, now, look at what you found. This is the exact same equation as the one you should put in question 11A1. Yeah, okay, I think if I remember correctly, none of the students get this question right, which is a bit surprising. Okay, yeah, so you need to, you can actually write this down from the beginning, okay, from this step. So put this down if you don't know the answer, okay? You have 2, this is the equation, 2H plus CO3 2 minus, forming CO2 and H2O. That's how you get this equation from before. So the positive test result. So let me just put down some positive test result here. So these are the positive test result. Positive test result. What about the positive test result from here? When you get carbon dioxide as a product, what will you see? If a reaction produces carbon dioxide, what do you see? When you open a can of Coke, what do you see? You see colorless gas bubble. You have to say colorless. Yeah, you have to say colorless. You can't just say gas bubble. Right. Yeah, so colorless gas bubble. Yeah, right this down. You can, however, not say carbon dioxide is produced because that's not an observation.
But that's just used.
That's just you interpreting the result. So write down colorless gas bubbles. There's a word that we can also use. Is effervescence. Effervescence means bubbling. Effervescence. Okay, effervescence means. And if there's no carbonate, then there will just be no bubbles. Yeah, you don't have to even mention the color because there will just not be any gas at all. So that's the third test. In this question, there is the fourth test. Is the test for ammonium ion. To test for ammonium ion, we can add sodium hydroxide. Okay, we can add sodium hydroxide. So you can put down test number 4. Is sodium hydroxide or potassium hydroxide because it's the hydroxide ion that matters. Okay, so potassium hydroxide. Yeah, anything with OH minus. What do they test for? They test for ammonium ion. So let me ask you once again, what is the formula of ammonium? Not ammonia, but ammonium ion. Na4 plus. Na4 plus. Na4 plus. It's a cation, okay, ammonium ion. So before we write down the positive results, okay, I want you to copy this equation first. When ammonium ion reacts with hydroxide ion, 2 products will form. Okay, a pair of products will form. Can anyone tell me what these products are? NH4, sorry, this is NH4 plus, sorry. This is NH4 plus. NH3 and H2O, water. So NH3, have you prepared this in the lab before? No. Oh, yeah, and that's probably because the teacher doesn't want you to smell it. This is a very, very bad smelling chemical. field. Okay, so
Oh, no, I'm done with that.
yeah, so you might not want to do experiment on this, trust me. Okay, so the positive test result is that it produces a very pungent gas. Okay, a pungent gas is detected. Okay, which is really ammonia. But you make sure you don't write out ammonia in the exam because that's not something you can observe. I mean, it's not written on the gas or there's any free on the gas like coming out. No, no. So a pungent gas is produced. But to confirm that this is ammonia, we put some kind of limits. What kind of limits do we use to prove that a gas is ammonia? Red. So some say red limit, some say blue limit. All of them are, all of you are correct. Because it says moist red limit. Yeah, red doesn't cut it. So that can turn, yeah, it's better that you make mistake here than in public exam. Okay, so that can turn, write this down. Moist red litmus blue. Because if it was not moist, it will not turn the litmus blue, even if you use a red one. Okay? And the negative result will be, of course, there is no pungent gas. Okay, so no gas. Okay, produced. Right, so therefore, can you answer this question? For question 6, you added sodium hydroxide to it. A pungent smell is detected. Underline a pungent smell is detected, and write down ammonium ion must be present. Yeah. And underline colorless gas bubbles evolve. Yeah, in the first sentence. In the second sentence. That means which ion is present. When you add acid into something, and then there is a colorless gas bubble produced, there's carbonate, okay, ion. So that means this substance, whatever it is, it must contain some carbonate and some ammonium ion. So when you do the crisscross rule, can you tell me what's the formula and also the name of this compound? Ammonium carbonate, what's the formula? CO3, yes, right on the name. Ammonium carbonate. Okay? So making the answer dot, T for dot. So which of the following will dissolve? Oh, this part if you don't remember, let me tell you what you need to review. Is this very complicated? This one. So I will let you look at this table and answer this question, but you have to remember this. And okay, how do you remember this? Okay, you can remember the 5 precipitate that are white first. Or if you're unsure, it's better to guess white. Because they are a lot more white precipitate than there are any other. Okay, but of course I'm not encouraging you to guess answer. So can you tell me which will dissolve to form a colorless solution when excess? Underline the word excess. Excess ammonia. Did you see this part of the table? What they are right here in this table? Excess ammonia. Where I put a tick, okay, is what will be dissolved, okay, to form a solution when excess ammonia is added. So you can see that zinc, silver, and copper, they are like the free ions that can be dissolved in excess ammonia. Yeah, but then we have, let me just check. So we have silver, copper, so which of the following metal ion when excess ammonia is added? Okay. So we have copper. Wait a second. So for this, oh right. For question 7, there are 2 precipitates you see, or I should say 3, that will be dissolved to form a color form a solution, right? But not all will form a colorless solution. Underline the other important keyword in the question. Colorless. Okay. When copper will dissolve, okay, I'll add this in here. When copper ion, you add a bit of ammonia into it, it will turn into a blue precipitate. So, right, okay. Don't worry, you can refer back to the recording later. So yeah, okay. Just can correct. Okay. So we have copper 2 plus a blue solution. When you add a bit of ammonia, okay, a bit of ammonia into it, it will turn into a blue precipitate. Yeah, an insoluble precipitate. Let's take to the bottom. So you have blue precipitate. Interestingly, if you add more ammonia, okay, it's almost so that it is added in excess, okay, it will redissolve back into a blue solution. Okay, you will get back, actually I can just copy this. Yeah, it will give you back a blue solution. So the formula of this you don't have to know. Okay, yeah, but then you have to know that it will redissolve into a blue solution. Silver ion is similar, but it is only similar in that it dissolves back into a solution. The color of silver is colorless, of course. Okay? So silver ion is a colorless solution. Yeah, when you add a bit of ammonia into it, do you all remember this table from before? When you add a bit of ammonia into silver ion, it will turn into a brown precipitate. It turns into brown precipitate. But this brown precipitate will redissolve into a colorless solution. So let me draw something brown in here. This is actually Ag2O. So Ag2O. So we need to remember the color. So brown precipitate. But this brown precipitate will then redissolve. Yeah, again, you don't need to know what this formula is. Okay, yeah. But you have to remember the resultant color. And it is that a colorless solution will form. So therefore, to this question, you can first eliminate option B and D. Because B and D, they do not redissolve. Okay, if you refer back to the table here, you can see that B will form PbOH2, this one, right? Option B will form PbOH2 when you add hydroxide into it. Does PbOH2 redissolve in ammonia? No. So B and D are out because they cannot redissolve in excess ammonia. Then why is C out as well? C is out not because it cannot redissolve, but because it redissolves into a blue solution. Okay, yeah, this is one tricky question. Okay, and the next one. So question 8. Let me tell you, there will be many questions like question 8 in your test tomorrow. So, okay. Well, at this point, I expect you to be able to solve this type of problem. Remember what to do? We find out the mole of the known substance first. Okay, so we have question 8 here. You have what volume of 0.2 molar H2SO4 is needed? Okay, so it's needed to neutralize 25.0 cm3 of 0.3 mNaOH. Just by reading this sentence, can you tell me which chemical do you know all the information you need to find a mole? NaOH. Yeah. So that's it. Apply this on to tomorrow's test, please. Okay. So you have V. This is the M. This is the V. Or you can also call it C. Doesn't matter. C means conjugation. M means polarity. So C is conjugation. M means polarity, and they mean the same thing. Okay. So C equals M in chemistry. Okay, so you first do N equals CV, and you find a mole of NaOH, put it on the calculator. Tell me what's the answer. Yes, okay, you need to first correct the CN tip into DN tip first. Okay, so you have N equals C times V, which is equal to 0.3 times 25 divided by 1,000. This is to turn CN tip to DN tip. Then you have 7.5 times 10 to the power negative 3, right? Yeah, mole. Now, the next thing that you do is to write me an equation. How does NaOH react with H2SO4? Can you tell me? Can you tell me all the products on the right as well as the proper ratio in front of each other? I give you 20 seconds. Yeah, what is the salt? Na2SO4 and 2H2O. Well, that means what do you need to put in front of? It's 2NaOH. Yes, 2NaOH. Now, focus only on the reactants. The ratio linking NaOH to H2SO4 is 2 to 1. That means the mole of H2SO4, should it be half or twice? Think carefully. should mole of H2SO4 be half that of NaOH or twice that of NaOH based on the 2-to-1 ratio? Think. Half. Yes, half. So therefore, this will be 1/2 the mole. Yeah. For those of you who don't know why this is 1/2, you can put the target mole ratio on top. This is always the target mole ratio as the numerator. What do we mean by target? Okay, NaOH is the known one, right? H2SO4 is the unknown one. You are trying to get from the known mole to the unknown mole. That means this is the target mole ratio. You divide the target mole ratio by the starting mole ratio. So this is the starting mole ratio. This is your target mole ratio. Okay? Then that way you will always get the right answer. Even if the mole ratio are any more weird than 1 and 2. Even if it's 3 to 4, you will still not take a chance. You will still know what to put there. So starting mole ratio, yeah, this is important. Especially if you keep making mistakes on which mole ratio to put on top. This will help you. This will save you. Okay? So starting mole ratio is at the bottom. The target mole ratio is on top. And then you multiply by the mole of NaOH, which you just found to be 7.5 times 10 to the power negative 3. So type it on the calculator. What does it give? When you divide 7.5 times 10 to the power negative 3 by 2. Yeah, or 3.75 times 10 to the power negative 3 mole. We are not done, but we are getting there. What is the volume? How do you find volume? If this is how you find mole. If N is equal to CV, how do you find V? N over C. Right. So lastly, you can go down. You see this equation. You must know before tomorrow's test. I mean, you should have known before the previous test, not before tomorrow's test. So V is N over C. We will use that now. We use N equals CV here. We will now use V equals N over C here again. Okay, where we plug 3.75 times 10 to the power negative 3. What's the concentration? According to the question, 0.2. Yeah, but don't be so happy. When you get the answer, what unit is it in? The unit is in DNQ, the one straight from the calculator. How do you convert that to CNQ? Times 1,000. So type it all on the calculator. So you have, so this is the answer, 18.75. Okay, yeah. In the SC exam, they will trick you by including the answer before you multiply by 1,000. And if you pick this one, you got straight. Yeah, this question is already being very, kind. It did not show you 0.01 and 0.5 as one of the answer. Okay, so the answer is C. Okay, once again, question 9. You must know this. Which of the following do not turn dry blue litmus paper red? What do you think is the answer? Can lime water turn blue litmus paper red? It cannot, because lime water is alkaline. It must not turn red. What is the color of litmus in alkaline condition? It's blue. Do you remember litmus? What is litmus paper for? Litmus paper is for testing for acids and base substance. When you put litmus into alkaline solution, it turns blue. So this is an alkaline solution. The red litmus will turn blue. When you put blue litmus into acidic solution, it turns red. So it turns red. So this is acidic solution. So litmus, put down an introductory sentence on all. Okay, so litmus will turn blue in alkaline condition and red in acidic condition. Okay? And they have to both be solution, because solution means what is present. When you say you have a solution, what is inside the solution? Water. Okay? Solution, the word solution is very important. Water must be present. So water must be present. If you want litmus paper to work, Okay, so but then you see this is a dry litmus, meaning on its own it won't work. But what does lime water have? Look at the word water. There's water, right? Yeah, so you can write down option number 1. Lime water. What's the chemical formula of lime water again? CaOH2. When CaOH2 is dry, there is no hydroxide ion. But because there is water, the water will go in here, split the calcium hydroxide into Ca2 plus and 2OH minus, and this will cause the litmus to turn blue. So does it turn litmus red then? No. Option 1 is out. And when option 1 is, so here, option 1 is out, okay, then you can eliminate A, B, and D. Eliminate A, B, and D. Okay? So, which do not turn dry litmus paper blue? Okay, so number 1 is the correct answer. Okay, but you see many of these options, they still have option 1 in it, so we have to keep trying. What about carbon dioxide gas? Is carbon dioxide gas acidic? No, because what does the word carbon dioxide gas mean? Does it have water? No. So carbon dioxide, it can potentially be an acid, but because it says carbon dioxide gas, it means there's no H2O present. So if there's no H2O present, carbon dioxide cannot be turned into which acid? What is the name of that acid that is always tied to carbon dioxide? Carbonic acid. You all know carbonated water, carbonated drinks, soda water. They all mean there's carbonic acid in it, H2CO3. And H2CO3 cannot split into H plus and HCO3 minus. So without H plus, would it be able to turn litmus paper red? No. Okay, so potentially it can turn red if there's water. I mean, if there's water, it can just keep going. CO2 and H2O can become H2CO3. H2CO3 can become H plus. But because there's no water, these reactions cannot happen. If these reactions cannot happen, there will be no H plus. Okay, so no H2O means no H plus. No H plus means does not turn red. Okay, so does not turn red. So therefore, the second option, carbon dioxide gas, will also not turn blue litmus paper red. So 1 and 2, they are still the answer. But we have to check whether 3 is correct because we have A and B left. What about citric acid crystal? It does, yeah, this is not a solution. Okay, so therefore, put down these requirements for me. For something to be basic and for something to be acidic, what requirements do they have to check? Yeah, water. First of all, they must both have water. So I'll copy this first. So they must. Okay, yeah, I'll wrap this up. Okay, so yeah, so I will soon as well. Yeah, or you can, if you really have to leave, you can walk. I will post it on the Google Classroom and YouTube later. So for something to be basic, H2O must be present. Okay, for both of them. Yeah. And so therefore pay attention when you see words like dry. When it is dry, even if you think that it's an acidic substance, it's just potentially acidic. It cannot be acidic if there's no water. If things are dry, they must not be acidic or basic. Yeah, so there must be water in it. And for something to be basic, okay, they must have oxide. Yeah, they must be oxide or hydroxide or ammonia. Okay? So these are the requirements that they have to check. They must be either an oxide, or an hydroxide, or an ammonia. What about for something to be acidic? H2O must be present, and which atom must be found in all acids? What kind of atom is found in all acids? H. Yeah, so when you talk about atoms, there will be H. Yeah, because you will never know whether the H can ionize to form H plus, right? Until water is present. Yeah, so they must contain hydrogen. Yeah, they must contain hydrogen, which can be ionized. when H2O is present. Okay? Right, yeah, I hear the noise as well. Okay, so therefore, can you determine one last question? Which of the following is acidic? So which is or are acidic? Okay, we'll see. So we have dry SO2, we have HClAQ, we have CH4, we have yeah, maybe these three only. So which of this is or are acidic? B only. B only. Okay? The first one is not because it is dry. The third one is not because it does not contain ionizable hydrogen, and also it is a gas. Okay? And it also does not ionize. Okay? So therefore, cross and cross. So which of this is basic? So which is basic? Is or are basic? So is or are basic? So you have A, dry ammonia. So yeah, number 2, lime water. Number 3, yeah, number 3 you have, what else? Number 3 you have Na2O plus water. A first, what do you think? No, because it's dry. B, yes, not only because it is basic, but also because there is water. Yes. What about the third one? Yes, because can you complete the equation? Remember what oxide reacts with water to give? Hydroxide, and compound by the fact that there is water in here, the sodium hydroxide will dissociate into plus and OH minus, so making C also the answer. Okay? Yeah, it's like playing with words, okay? So you should be very careful with the wording. Whether it's dry, whether it's wet, whether they are metal oxides, whether they are non-metal oxides, and other things. So let me remind you one today. I don't want to remind you all, but tomorrow we are doing it.
So why?
Why? I thought you requested to retest. If you requested to retest.
Sorry,
Yeah.
because we have test tomorrow as well, then it's fine.
Well, that I could not have anticipated. Okay, but yeah.
So you can give us tips for tomorrow. How
No
many tips?
tips. There's no
Sir,
tips.
why not?
Like, what's the point? Do you get tips for DSE exam? No. Okay. If I give you tips, I'm just
Sir, if you pay attention to the past papers, yes.
no.
Sir, needs.
I can tell you that it's similar to this paper. Maybe I made it a little bit easier this time. Yeah. Okay. So you just not to hamper your confidence. Okay. Yeah. But I mean, it's not about hampering your confidence or not, but it's about testing your understanding of concept. If you understood what I just said, you probably do just fine in tomorrow. But everything in the test, I can assure you, is something related to what we discussed. Okay? Yeah, but we'll see. Bring your calculator and bring yourself to school tomorrow. Yeah, okay. Because a few students missed the previous test and they had blank pages. I can't believe this. Blank pages. This is unacceptable. They are not even trying. Okay, yeah, so.
Sir, is the answer for the test in your classroom?
I'll upload this. Okay, I'll upload this. I have it in here. Okay, I'll paste it onto Google. I'll upload it on Google later. Yeah, not yet. Yeah. Okay. So I'll post it later.
So the test is going to be similar to that. We're doing a same.
No, of course not the same. What's the point of doing the same test?
I made different number.
No. No. Not like in math class. Yeah, I'm not sure how you do the math class, but I can't just change the number. Okay? Yeah. I have to change the entire question. Okay? So good luck. Bring a calculator and come back to school. Okay? Tomorrow. texture.
Yeah,
So
it's
the
like
mold
a
is
old
actually-
texture.
So the mold.
This guy's
His head is so white.
His hair looks like feathers, and it's so soft, like it moves with the smallest amount of movement.
Yeah, so it's kind of like you have. So the question here, I think the question is like a person.
I'm pretty sure it's the things you have to do. Yeah, the top is like down.